Hello, welcome to the fourth week's lectures of Programming and Data Structures Theory course. My name is Shagato and the topic of this week's lectures is one-dimensional arrays. So consider the following programming task. Given 5 integers as inputs, print them in reverse order. The user will enter 5 integers through the keyboard and your program will print out those same integers but in reverse order onto the screen. For instance, if the user enters 1, 2, 3, 4, 5, your program will print 5, 4, 3, 2, 1. Yeah? And let's say I ask you to write a program that accomplishes this using whatever we have taught you so far. So what will you do? You may define 5 integer variables to store the 5 integers that the user will enter through the keyboard and name them A, B, C, D, E. Yeah? And then the user enters 5 integers through the keyboard and using the scanf function, you store those 5 integers in these 5 variables. So the first number is stored in A, the second in B, the third in C, the fourth in D, and the fifth in E. Yeah? And now you print those numbers, but you print E first, followed by D, followed by C, followed by B, followed by A. Yeah? So this way you can print those numbers in reverse order. There is no problem with this code and it will have the desired output. However, this is a code which can handle 5 integers. But what if the number of integers is very large? For instance, let's say I ask you to write the same program but with 1000 integers. Then what will you do? Use 1000 integer variables? That does not sound feasible. This is where arrays come in. An array is a data structure. Array is a data structure which can represent a collection of data items which have the same data type. And this is exactly that we need here. We need a mechanism to be able to define 1000 integers and a way to access each one of them. So let me introduce arrays to you through an example. Here is a program that takes in some number of inputs, integer inputs from the user and print those integers in reverse order. Yeah? So let us go through this program. So the first line of the main function has 3 declarations. N and I are regular integer variables and you are familiar with these declarations. Capital A, square bracket 100. This is an array with 100 integers. So this declarative statement declares Ni, 2 integer variables N, I, and an integer array named A of size 100. Yeah. Now, this program is capable of handling a variable number of inputs. So the program begins by asking the user for the number of inputs that the user is going to enter. Yeah? So it prints onto the screen how many numbers to read. And the user enters a number. That number is stored in the integer variable N. Yeah? Then the program reads N many integers through the keyboard. This for loop does this. Here there is an index variable I that goes from 0 up to n minus 1, yeah, and it is incremented by 1 in each iteration. And this scanf statement takes the next integer that the user enters through the keyboard and stores it into the next cell in this array, if you like. Yeah. So this array can hold 100 integers. The user will enter n integers. We will assume here that n is at most 100, and then this loop takes in n integers through the keyboard. In each iteration, it takes one new integer and stores it in a new location in the array. So AI refers to the array element of index I. The index, the starting value of I is 0. So in the first iteration, the first number is stored in A within square bracket 0. A followed by a 0 within square bracket stands for the first number in the array. The index of the first number in the array is 0. The index of the second number is 1. And in general, index of the I plus first number is I. Yeah. So in the I plus first iteration of this loop, the memory location, the array location AI is filled with the I plus first element that the user enters. Yeah. Now at this point, n elements have been stored in the first n locations in this array. N could be much smaller than 100, and in that case, the remaining 100 minus n locations of this array are unused. Then the next for loop prints out those same n elements, integers, in reverse order. So it first prints the nth element, which corresponds to the index n minus 1, a n minus 1. In the next iteration, it prints the n minus 1th element, which corresponds to index n minus 2, and so on. So this for loop prints those n numbers in reverse order. Finally, it prints a new line and it returns. So before using an array needs to be declared, and this is how it's declared. Int x within square bracket 10. The int stands for the data type. All the elements of the array need to have the same data type. So this declaration serves to allocate a block large enough to hold 10 integers in the memory. This 10 refers to the number of integers that this block will contain, or also referred to as the size of the array. And individual elements are accessed by specifying the index. Yeah. So the first element of the array is x0. Yeah. The second element is x1. The third element is x2. And the 10th element is x9. So this is the 10th element of the array. Here is another example. The program defines an integer array named data, data, all small, of size 10. And then the program stores I in the location in the array data corresponding to index I. Recall that the index starts from 0 and the index 0 corresponds to the first element in the array. So the integer 0 is stored in the array location corresponding to index 0, that is the first array location. Integer 1 is stored in the array location corresponding to index 1, that is the secondary location, and so on. And integer 9 is stored in the array location corresponding to index 9, that is the 10th array location. Then the index variable is reassigned to 0, and in this while loop, the array elements are printed in order as follows. This printf statement prints capital DATA, then within the square bracket, the value of the integer I in that iteration, then this symbol equal to, and then in place of this %d, the value of the integer contained in the location in the array DATA data corresponding to index I. There is one thing that I want to point out here. This data, capital DATA, is just a string that printf prints out, whereas this data, which is one of the arguments of the printf function, corresponds to the array data that we have defined in this program. And this is the output that this program produces. And this is what we expected. In the first iteration, the array prints capital DATA within square bracket, the value of I in the first iteration, which is 0, then this equality symbol, and then the value of data I, that is the location of the array, the content of the location of the array data corresponding to the index I. In the first iteration, I is 0, so data 0, which is equal to 0. In the next iteration, capital DATA gets printed, followed by the opening square bracket, followed by the value of I in the next iteration, which is 1, followed by the closing square bracket, followed by this equality, followed by data of 1, because I is 1 here, which is 1, and this is what you see. And then after each iteration, you print a new line, so that in the next iteration, this line is printed in a fresh line. So like variables, the arrays used in a program must be declared before they are used, and the general syntax for array declaration is type followed by the array name, followed by opening square bracket, followed by an integer size, followed by the closing square bracket. Type specifies the type of the data type of the elements that will be contained in the array. So type could be int, float, char, etc. Size is an integer constant which indicates the maximum number of elements that can be stored inside the array. Here is an example. We have already seen few examples before. So int marks 5. Int specifies that this array will contain integer data. Marks is the name of the array, and the 5 specifies that the array will contain 5 integers. So this declaration defines this array declaration serves to allocate an array that can store a maximum of 5 integers. Here are some examples of declarations of array. Int x 10, char word 10, float distance 150, char name 35. Now, if we are not sure of the exact size of the array, we can define an array of a large size. Int marks 50. For instance, in the first program that we saw in this slide that introduced array, we were accepting n integers from the user, but the value of n was known a priori. So we defined an array of size 100, even though the actual number of elements could be less than 100. A particular element of the array can be accessed by specifying two things: name of the array and index or the relative position of the element of the array. Yeah. For instance, the name of the array could be word and the index could be 5. Yeah. This is how we will be able to access the 6th entry of the character array word. 6th character of the character array word. I am assuming that word is a character array here. So index 5 corresponds to the 6th element, because recall that the indexing begins from 0 and index 0 corresponds to the first element, index 1 corresponds to the second element, and so on. In C, the index of an array starts from 0. Here is another example. An array is defined as int x10. The first element of the array x can be accessed as x0, the fourth element as x3, the 10th element as x9, and so on. The array index must evaluate to an integer between 0 and n minus 1, where n is the maximum number of elements possible in the array. So for instance, in our first program, we defined an array of size 100. So in our program, every time we access an element of the array using an index, we should ensure that the index must evaluate to an integer between 0 and 99. Also, the index could be an expression that evaluates to an integer. In this example on the slide, we have a within square bracket x plus 2 is equal to 25. So here the index of the array a is x plus 2, which is an expression, and it evaluates to an integer depending on the value of x, and then the corresponding location of the array is assigned integer 25. Similarly, in the second example, the location of the array b corresponding to the index 3x minus y is assigned the evaluation of the expression a 10 minus x plus 5. 3x minus y is an expression that evaluates to an index. The location of the array b corresponding to that index is assigned the evaluation of the expression on the right. The evaluation on the expression on the right is, the content of the location of a corresponding to index 10 minus x. 10 minus x again is an expression. It evaluates to some number, and a 10 minus x corresponds to the location of a corresponding to that index 10 minus x, and then 5 is added to it, and the resultant number is assigned to b 3x minus y. So each element of an array is a variable by itself and can be used anywhere a variable can be used in expressions, assignments, conditions, etc. So here ax plus 2 can be thought of as an integer variable, assuming that A is an integer array. So AX plus 2 can be used pretty much anywhere a variable can be used. Here, for instance, an array element is used in an expression. In the right hand side of the second assignment statement on the slide. How is an array stored in memory? Okay, so when we define an array of a certain size, memory is allocated, space is allocated in memory in the following way. Starting from a given memory location, the successive array elements are allocated space in consecutive memory locations. Yeah? So, let us say that we define an array A, and let us say X is the starting address of the array in memory. Now, every byte in memory has an address, and if, say, A is an integer array, each memory location will be 4 bytes long, at least in my machine, yeah? And X will be the starting address of the 4 byte chunk that is allocated to the first element of the array A. So K is the number of bytes allocated per array per element. So if A is an integer array and we are working in my computer, then K is equal to 4. So K is equal to 4 bytes. A is an integer array. So AI is allocated memory location at address X plus I times K. So X plus 4K if K is equal to 4. So if the starting address of the array is X, that means the address of the first byte of the 4 byte block assigned to the allocated for the first element of A is X. The address of the first byte of the 4 byte block allocated to the second element of A is X plus 4, and so on. I'm sorry, I made a mistake. It should be 4i. Yeah. K is equal to 4. I made this substitution. So if I is equal to 0, that corresponds to the first element of A. Its starting address is X. If I is equal to 1, it corresponds to the second element of A. It's a 4 byte object. The address of the first of those 4 bytes is X plus 4, and so on. Okay. You may try it out by writing a program. You may try printing the addresses of the various locations of an array by writing a program, and you can print the address using the ampersand operator. The ampersand operator returns the address of a variable. You have seen ampersand operator in the scanf function. So in this program that you can see on the screen, here we define an integer array data of size 10, and then in a for loop we print the address of each element of the array. So in the first iteration of this for loop, you print ampersand data, opening square bracket, then the value of I, which is 0, then closing square bracket, equal to the address of data I, data which is I for in the first iteration I is equal to 0. So ampersand data 0 refers to the address of the first location of data, and that gets printed here, and then you print a new line character, and in the next iteration you print the address of the second location of data. As you can see from the output, the addresses differ by 4. So this address in the first line 3221224480 refers to the X in the previous slide. Remember that X referred to the starting address of the array, yeah? And then K is equal to 4 here. So the next address is X plus 4, which is what you see here. The next address is X plus 2 into 4, which is what you see here, and so on. Initialization of arrays. This is the general form of initializing arrays. Type followed by array name within bracket size equal to opening curly bracket, a list of values comma separated, then closing curly bracket and semicolon. Here are some examples. Int marks 5 is equal to, then inside curly brackets 72, 83, 65, 80, 76, and then semicolon. So inside curly bracket you write a comma separated list of values. So it assigns 72 to the first location in marks, that is marks 0 is 72, then assigns 83 to marks 1, 65 to marks 4, marks 2, 80 to marks 3, and 76 to marks 4. Similarly, char name 4 can be initialized as follows. You write char name 4 equal to, then within curly brackets, a comma separated list of character constants. Each character constant is a symbol enclosed in single quotes. So capital A within single quotes stands for the character constant capital A. Same for small m, small I, and small t. The size may be omitted because the compiler can easily figure out from the list on the right the size of the array. For instance, down here, if I write int flag, then a square bracket which is empty equal to a list of 4 integers, the compiler can easily figure out that it should allocate enough space to hold 4 integers. Similarly, char name followed by an empty square bracket is equal to then within curly braces a comma separated list of character constants followed by a semicolon. So here again, by looking at the list on the right, the compiler knows that it should allocate space enough to hold 4 character constants. How to read the elements of an array? So let's say some user is entering elements through the keyboard and we are supposed to read them into an array. Yeah? We can use the scanf program to read one element at a time. Recall that we said that the array elements can be used anywhere a variable can be used. So we use scanf to store to read from the keyboard elements into various locations of the array. So here we have a for loop that reads 25 double variables, 25 fractions, yeah, of type double into this array A, yeah, and the format of scanf, as you can see, is a format specifier string, a string containing a format specifier %f, followed by a comma, followed by ampersand a bracket j. The ampersand is necessary, and for the same reason why it is necessary, while reading reading values into variables, we need to specify the function scanf, the address into which the variables are to be read, the values are to be read. The elements can be entered all in one line or in different lines. This is the end of this video, and we'll continue in the next video. Thank you.